Recurrent neural networks or RNNs. Recurrent neural networks are neural networks designed for sequential data such as time series, language, or speech. RNNs have connections that form cycles, allowing them to retain information from previous steps in the sequence. This makes RNNs well suited for tasks like text generation, language modeling, and time series forecasting. A common variant or long short term memory LSTM helps to address the issue of long term dependency, which we'll look at in the next video. But for now, we're going to look at RNNs. So, first, let's go ahead and implement line by line using Python recurrent neural networks. I've already created a file called as rnns.py. The first steps is to import libraries. So I'm going to import the libraries. First one is TensorFlow STF. This is the main library for deep learning, providing tools to define and train neural networks. Next, I have layers and models from TensorFlow.keras. These keras modules in TensorFlow used to define the layers and structure of the neural network. Then IMDb, a dataset of movie reviews from TensorFlow's keras.datasets, with each review labeled as positive or negative sentiment. Sequence, a utility for pre-processing sequences specifically to pad or truncate sequences to the same length. This is from tensorflow.keras.preprocessing. Next, let's go ahead and load and pre-process the IMDb dataset. First, max features equal to 10,000. This is the vocabulary size, and max length is 500. The max features sets the vocabulary size to the top 10,000 most frequent words in the dataset. The max length limits each movie review to 500 words. Now, reviews longer than 500 words will be truncated, while shorter ones will be padded. So, let's go ahead and next create the xtrain, ytrain, xtest, ytest equal to imdb dot load data number of words equal to max features. This loads the IMDb dataset, limiting it to max features, most frequent words. Xtrain and ytrain are the training data and labels. Each review is represented as a sequence of integers, which are word indices, and then xtest and ytest are test data and labels. Let's go ahead and say xtrain equal to sequence dot pad sequences x underscore train max length equal to max length. This pads or truncates each review in x underscore train to ensure all the reviews have exactly max length words. And xtest equal to sequence dot pad sequences xtest comma max length. This similarly, xtest is padded or truncated to max length. This step ensures that each review is the same length, which is necessary for batch processing in neural networks. Let's go ahead and define the RNN model now. Model equal to models dot sequential, which defines a sequential model where each layer output is passed to the next layer. So let's go ahead and create the first layer. We have layers dot embedding max features comma 32 comma input length equal to max length. The embedding layer that converts word indices into dense vectors of fixed size is enabled here. The max features is the vocabulary size, limiting embedding to the top 10,000 words. 32 is the size of each word vector, which is the embedding dimension. And input length equal to max length. This is the length of the input sequences, which is 500 number of words per review. So once I've done that, I'm going to say layers.simple RNN with 32 as a parameter. This is simple RNN layer with 32 units, which processes the sequence data. Next, I have layers.dense, one activation equal to sigmoid. This is the output layer with one unit and a sigmoid activation function. The one is the parameter represents a single output neuron predicting the probability of a positive or negative sentiment. Activation equal to sigmoid. Sigmoid activation functions outputs a probability between 0 and 1 suitable for binary classification. Let's go ahead and close it and compile the model next. Move it a little up, model.compile, optimizer Adam, loss equal to binary cross entropy, matrix equal to accuracy. So here this configures the model for training. Optimizer equal to Adam uses the Adam optimizer, which adjusts learning rates based on momentum and adaptive learning rates. loss equal to binary cross entropy. The binary cross entropy loss function is suitable for binary classification task, which is in this case sentiment analysis. Matrix equal to accuracy, which specifies accuracy as the evaluation metric. So let's go ahead and train the model. So to train the model, I'm going to say model.fit, which trains the model on the training data, where I'm passing x train, y train, which is the trailing data and labels, the training data and labels. Epochs equal to 5 is the number of times the model will go through the entire training data set. Batch size equal to 64, which is number of samples per batch for gradient updates, improving computational efficiency. And validation split equal to 0.2 reserves 20% of the training data for validation, allowing the model to evaluate performance on unseen data during training. Let's go ahead and evaluate the model now. Test loss, test accuracy equal to model.evaluate x test, y test, and I'm going to print the accuracy. So the model.evaluate function evaluates the model on the test set, returning the test loss and accuracy. The x underscore test, y underscore test are the test data and label. We have test loss, which is the calculated loss on the test data, and the test ACC is the accuracy of the model on the test data. And then finally print. So let's go ahead, save it, open your terminal, and say Python RNNs.py. Run it. Again, it's going to do something similar as our previous project on CNNs, where it's going to run it for 5 epochs. So it's going to go ahead and run it first time. I'm going to fast forward it to the 5th time and then go from there. So we are almost done here. Let's see what is the accuracy that we get for the model for testing sentiment analysis, where we have written the algorithm using RNNs. So we should have it as soon as this completes the entire step here. And there you go. Test accuracy is 81%, which is not bad for sentiment analysis because it's much difficult sometimes based on the big data set that we have here to get the best option. And as you can see, it doesn't have much data, so this is pretty good as per the accuracy goes. Accuracy is 80%, loss is 53%. That's good. Higher the accuracy, better it is. So I hope you were able to follow along and implement this and you had similar results. If you see something else, errors, issues, or have any questions, let me know and I'll get back to you.